Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, we are going to learn about liquid state. You know my friend, solid state, liquid state and gaseous state. These three very important chapter for chemist. So in this video, we will learn about liquid state. Liquid is a fluid that conforms to the shape of its container but retain a constant volume independent of pressure. You know my friend, it depends on the intermolecular forces, and on the basis of that we can differentiate solid, liquid and gases. So types of intermolecular forces in liquids. We have to study these interactions because this interaction will decide the liquid states. So whenever we are going to learn about liquids, we have to learn about dipole-dipole attractions, London forces and hydrogen bonding. You know, dipole-dipole attractions, London forces and hydrogen bonding, you can see in this table. Covalent bond 400 kilocalorie, hydrogen bonding 12 to 60 kilocalorie, dipole-dipole attraction 2 to 0.5 kilocalorie and London forces less than 1 kilocalorie. So relative strength for the different interactions, covalent bonds, hydrogen bonding, dipole-dipole attractions and London forces. Now dipole-dipole attractions. Dipole-dipole attraction exists between molecules and that are polar, and this requires the presence of molar bonds, polar bonds and an unsymmetrical molecules. Unsymmetrical molecules like Cl, you can see this is a polar bonds HCl, and this is representations of polarity, positive and negative. Now take it out this and put it here and see the attractions. So positive, negative, positive, negative, positive, negative, negative, positive. So this is the weak interaction, and these attractions you can also see in this HCl molecule. So weak attractions between polar HCl hydrochloric acid molecule. Now you can see in this pictorial diagram London forces. London forces exist in non-polar molecule. You can see electrostatic attractions and helium atom 1 and helium atom 2. You know there is a no polarity here. So London forces exist in non-polar molecules. Now you can see the polarity it developed, positive and negative. So you can see in this pictorial diagram how these non-polar molecules become polar. So you can see this molecule N-pentane and neopentane both have this structure like this. N-pentane boiling point 36 and neopentane boiling point 9.7 degrees Celsius. Now you understand why this much differences in the boiling point of N-pentane and neopentane. Now, hydrogen bonding, HB. Hydrogen bonding is a unique type of intermolecular attraction, and there are two requirements: covalent bond between an hydrogen atom and either fluorine, oxygen or nitrogen, and other atoms nowadays also people thinking there is attractions. So these are the three most electronegative elements. Now, interactions of the hydrogen atom in this kind of polar bonds with a lone pair of electrons are nearby atom like fluorine, oxygen and nitrogens. Look at this hydrogen bonding between the water molecules. This is partially negative charge on oxygen and partially positive charge on hydrogen, and due to this charge there is a attraction between oxygen and hydrogen. Oxygen belongs to the other molecules and this is the another molecules. So this attraction is hydrogen bonding. Now you can see in ammonia, nitrogen have partially negative charge and one of the hydrogen atom of ammonia out of three involved in the hydrogen bonding and other. So in pictorial diagram you can see how hydrogen bonding exists in water molecules and ammonia. So you can see the effect of hydrogen bonding on boiling points. So molecular mass, that is normal boiling points. Water, H2S, H2SE and H2T. You can see the first member have this group oxygen, sulfur, selenium, tellurium. Water have high boiling point in comparison to H2S. Why? Why this changing? Due to hydrogen bonding. Now you can see the CH4, silane, gerane and steinane. So methane to steinane, how much differences here in negative? So due to hydrogen bonding. The effect of hydrogen bonding on boiling point. My friends, so summary of the types of intermolecular forces. What kind of substance? Metallic elements, metallic bonds, diamond, covalent bonds and other non-metallic elements, London forces, ionic compound, ionic bonds, molecular compounds to the molecular carbon OH, NH and HF bonds. So we have the, if it is present, yes, hydrogen bonds, no, are any bonds polar? If polars, then symmetrical or asymmetrical arrangement of polar bonds. If no, London forces. Now you can see there is a asymmetric, then dipole-dipole attraction, symmetric London forces. So this summarize types of intermolecular forces is very important. Now my friends, I hope I have to stop here. I will make another video on liquid states and I will upload it. So my friends, I hope this video will be fruitful for you. If you like this video, then subscribe my channel and thanks for watching.